All right, let's take a look at definite integrals using trig. Now, before we start doing any of the integrals, just in the way of a review, a reminder, here's a table of the derivatives and the antiderivatives of the trig functions. So the ones that we are going to be working on will be the ones on the right-hand side here, and we'll refer back to these as we find these. So anyway, just a reminder of what the antiderivatives of the trig functions look like. So now with that in mind, let's take a look at a first problem. Okay, what we've got is this. You want to find the integral of the sine of x from 0 to 2 pi. Now, before we go through the math, let's take a look at a picture and get an idea of what this thing looks like. So what you've got, we want to go from 0 to 2 pi, so it will actually be starting about right here, and it's going to go all the way across to right here. So from 0 to 2 pi, and what that's going to give you is this, is the integral under this between the function and the x-axis. So you'll wind up with a positive area here and a negative area down here. Now before we start the problem, you can kind of look at it and tell. The area above the curve is exactly the same thing as the area below the curve, so those two are going to cancel out, and the final answer should be 0. So that's visually what it looks like, but now let's try it mathematically and see what we come up with. So the first step here is to do the following. Find the antiderivative of the sine of x. Now let's go back to our table, and you can look at this. The antiderivative of the sine of x is the negative of the cosine of x. So with that in mind, let's do the following. So the antiderivative of the sine of x would be the negative of the cosine of x. And we want to evaluate this from 0 to 2 pi. So just like you've done in the past, go ahead and plug in the top number minus the bottom number. So this is going to be the negative of the cosine, and plug in the 2 pi, so plug in the top number, minus the negative of the cosine of 0. So it looks like that. Well, the cosine of 2 pi is 1, so this will turn into a negative 1. Minus the negative of the cosine of 0, which is also 1. So it gives you this. And what you wind up with, then you've got a negative 1. Two negatives make a positive 1. Add those together and you get 0, and that's going to be the answer to this problem. So again, find the antiderivative of the sine, which is the negative of the cosine, plug in the top number, plug in the bottom number, evaluate them, and you come up with this. And again, you're expecting a 0 because the area above the function is, or above the x-axis is exactly the same thing as it is below the x-axis. Okay, now let's take a look at exactly the same problem, but change the limits and see what that does to the answer. Okay, let's look at this problem. Now it's still just the integral of the sine of x, but this time we're going to go from from pi divided by 4 to 4 pi divided by 3. So visually what it looks like is this. You're going to go from here at pi divided by 4 to here at 4 pi divided by 3. So we're going to evaluate it from here to here. Now this time if you look at it, the area above the curve is greater than the area below the curve. So you're expecting the final answer is going to be positive. So what we'll have is this area in here, and then this little area down in here. But since there's more above than there is below, the final answer should be positive. So with that in mind, let's see what we get. Now just like before, the antiderivative of the sine is going to be the negative of the cosine. So this will be the negative of the cosine of x, evaluated from let's see, pi divided by 4 to 4 pi divided by 3. All right, so just like you've done before, plug in the top number and plug in the bottom number. So this will be the negative of the cosine, and plug in the top number, which is 4 pi divided by 3. Then minus, and plug in the bottom number, which would be the negative of the cosine of pi divided by 4. And you've got that. Now you want the exact answers on these, so really it just kind of comes down to whether or not you remember your trig functions or not. So with this in mind, let's real quickly run over here and let's find that, what the cosine of 4 pi divided by 3 looks like. Well, first of all, I'm going to draw a picture of a 4 pi divided by 3 angle. And it would look something like this if I put my circle up here. 4 pi divided by 3 is about right here. It looked like this. So it's going to be something like that. And that is 4 pi divided by 3. Now, if you remember your special angles, this is going to be 2, a negative 1, and this side would be square root of 3. And you want the cosine, which is x over r, so it's going to be minus 1 over 2. So what this one's going to be would be the negative, and the cosine of 4 pi divided by 3 is x over r minus 1/2. So that'll be a minus 1/2. Then you've got the negative. Now you've got the negative of. Now you want the cosine of pi divided by 4. So let's draw a picture of that angle and see what that looks like. So I'll draw a quick picture over here. Just a reminder. And a pi divided by 4 angle is a 45-degree angle, which would look, we'll do it in black here, it'll look something like this. It goes up like this, this, and this is pi divided by 4. Well, again, from your special angles, that's 1, 1, square root of 2. So the cosine is going to be x over r, so it'll be 1 over the square root of 2. So this thing's going to be 1 over the square root of 2. And I'll put a bracket around that. So the final answer in this case actually turns out to be the negative of a negative. This will turn out to be 1/2, and then 2 negatives make a positive, so plus 1 over the square root of 2. And that's going to be the final area. So that's going to be the answer to the problem. Now, if you were to stick this on a calculator, it will actually turn out to be about 1.21. So here is the decimal answer for that area, and then here is this. But in general, you're going to want the exact answer. So I'll put exact down here just to remind you. Generally, you want the exact answer to these problems. Okay, so there is a second definite integral. Now, let's take a look at another example. Okay, so what this one is, we want to find the antiderivative of 2 times the cosine of x from negative pi divided by 2 to pi divided by 6. Well, first of all, here's a cosine graph over here, so let's kind of take a look at what this is going to look like. You're going to go from negative pi divided by 2, which is about right here. Let's see, about right here. And you're going to go to pi divided by 6, which is only about right here. So we're going to go from here to here. So if you were to graph it, the area you're going to get will be this little area starting in here and it's going to go across like this. So visually, that's what it looks like, and we're going to calculate that area. So from minus pi divided by 2 to pi divided by 6. So let's go ahead and try this and see what we come up with. First of all, I'll go back to our definitions again, just to remind you, you want the antiderivative of the cosine. Well, the antiderivative of the cosine is the sine of x. So using that, we will have, here's the constant 2, and the antiderivative of the cosine is the sine of x, and that's going to be evaluated from negative pi divided by 2 to pi divided by 6. So as we've done in the past, go ahead and plug in the top number, 2, then you want the sine of pi divided by 6, then minus 2 times the sine, and this time plug in the negative pi divided by 2. Again, we want exact answers for these, so let's see what this looks like. I've got the constant 2. Now, first of all, I need to know what is the sine of pi divided by 6. So again, I'll draw a quick picture of it just to remind you of your trig. So the angle itself, here's a circle. A pi divided by 6 angle is a 30-degree angle. It would look something like this right here, about right there. So that's going to be a pi divided by 6 angle. Now the sides of this thing are going to be, this will be 2, this is 1, this side is the square root of 3. And you want the sine. Now the sine is y over r, so in this case it would be 1/2. So the sine of a pi divided by 6 angle would be 1/2. So that's where the fraction comes from. Then you want 2, this time you want the sine of negative pi divided by 2. Well, let's take a look at that angle. Where it would be right here. So negative pi divided by 2 goes straight down like that, and that's negative pi divided by 2. So it's a negative 90-degree angle. Now, the sine of a negative 90-degree angle is negative 1. So what this is going to give you is, first of all, the 2's will cancel out here. So that 2 cancels out that 2 and leaves you with a 1. Then 2 negatives make a positive. That'll turn into a positive 2. 2 plus 1 would be 3. And that is the area between negative pi divided by 2 and pi divided by 6. So just remember, the hard part probably is the trig part, is just remembering your exact values of your trig angles. And if it helps, draw a little circle of it like this and get the exact values off that. All right, let's try another example. Okay, now you can have problems that have this, a combination of trig and non-trig together. So just treat them as two separate things. Let's go ahead and just run through this one. What this would be first of all, we'll have, find the antiderivative of 3x. Well, what that's going to be is 3, then the antiderivative of this would be x squared divided by 2. So just use the power rule on that thing. Then you've got minus 4. Now you need the antiderivative of the secant tangent. Let's go back to our list of definitions down here. The antiderivative of the secant tangent is the secant of x. So the antiderivative of the secant tangent turns into the secant of x. And I want to evaluate that from minus pi divided by 3 to pi divided by 4. Okay, so what this is going to give us would be, and again, just plug in the top number and the bottom number. This one would be 3 halves, and in place of x, put what it's equal to. So it would be pi divided by 4 squared. Minus 4 times the secant of pi divided by 4. So there's the function evaluated at the top number, minus, now plug in the bottom number. So you've got 3 halves of negative pi divided by 3 squared minus 4 times the secant of negative pi divided by 3. Now, sometimes you get some kind of strange answers on these, and you just have to stay with what you've got. On this one, if you, first of all, square the pi and square the 4, so that's going to give you 3 halves. This will become pi squared divided by 16 in parentheses. So square the pi and square the 4. Then minus 4, and let's find out what the secant of pi divided by 4 is. So again, this problem kind of comes back to whether or not you remember your trig functions or not. So first of all, draw yourself a picture of a pi divided by 4 angle. So it will look something like this. So again, pi divided by 4 is a 45-degree angle, so it'll look about like this. So you got pi divided by 4. Now remember, for a pi divided by 4, it's for the special angles, this side is 1, 1, and square root of 2. You have to know your trig functions. Okay, well the secant is r over x, so it's going to be square root of 2 over 1. So this will wind up being square root of 2 over 1. And just a reminder, what that is r over x. So r is square root of 2, x is 1. Okay, so that takes care of the top function. Now, same thing for the bottom function. So you're going to have 3 halves. Now when you square this, square the negative pi, it'll turn into a positive pi squared. 3 squared would be 9. Then minus 4. Now this time you've got the secant of a negative pi divided by 3 angle. Let's take a look at what that one looks like. So again, draw yourself a picture of it. It's going to look like this. So I'll put a circle up here. It looks kind of like this. Now, a negative pi divided by 3 would be a negative 60-degree angle. So it'll look something about like this right here. So that's negative pi divided by 3. Now label the sides. This, again, special angles. This would be 2, 1, and negative square root of 3. Well, again, the secant is r over x. So r is 2, x is 1. This will turn into 2 over 1. So probably the hard part of the problem is getting those two trig functions. Now at this point you can do the following. This first one, you can multiply these out. This will turn into 3 pi squared divided by 32. Then the second part is going to be minus 4 times the square root of 2. Then put this one together and it's going to be the negative of this thing. So this is going to give you negative 3 pi squared divided by 18. And then finally you've got 2 negatives make a positive. This will be plus 8. And that's going to be the exact answer. Now if you wanted to, you could divide 3 into 18 and get a 6. But basically this is the exact answer. So let's just stay with this for right now. So it'll look like this. I'm going to put a little line around this. Okay, so that's the exact answer. So occasionally you'll get some unusual looking answers that might have pi squared in it or some square roots or whatnot. Now if you did this, if you put this on your calculator and hit the enter button, it would turn out to be about 1.62. So this is the decimal answer. But again, what you're generally looking for is the exact answer. So just as a reminder, what you're going to usually want will be the exact answer right here. So it looks kind of strange, but there it is. All right, one more example. Okay, the reason we're going to look at this last example is sometimes you have to use identities. So we will keep an eye on this one. What it's going to be is a problem where you have to use trigonometric identities. Okay, now how do you know you have to do this? Well, let's go back to the original definitions. What I've got is 1 over the cosine squared. But the problem is that when I look through my list, I don't have an antiderivative for 1 over the cosine squared. But what I do have is an antiderivative for the secant squared. So if you remember your trig identities, 1 over the cosine squared is the secant squared, so take advantage of that identity. So what I'll have here will be the integral from, and I'll change it to this, from pi divided by 4 to pi divided by 3, and 1 over the cosine squared is the secant squared of x. So use your identity to change it into a form you can get. Now what this one's going to be, now let's go back to the definition list again. You do have the antiderivative of the secant squared is the tangent. So let's go ahead and use that. This will turn into the tangent of x evaluated from pi divided by 4 to pi divided by 3. Let's do what we've done before. Go ahead and plug in the top one. So this will be the tangent of pi divided by 3 minus the tangent of, let's see here, the tangent of, we'll get rid of that, of pi divided by 4. So again, plug in the top number, plug in the bottom number. Now we're back to the same old thing, finding the exact values of these derivatives. Let's draw another quick picture of each one. If I had a pi divided by 3 angle, looks like this. So pi divided by 3 is 60-degree angle. It'll look about like this right here. This is pi divided by 3. Now the exact values of the special angles would be 2, 1, and the square root of 3 on this side. So the tangent is y divided by x. So in this case, it would be the square root of 3 divided by 1. So just remember that you're looking for y divided by x in this case. So y divided by x. Then minus, now we need a pi divided by 4 angle. So let's draw a quick picture of that. So if I put my unit circle up here, or a circle, what I've got is pi divided by 4. So this one's going to look like this if you do your special angle. It's a 45-degree angle. So this is pi divided by 4, which is 1, 1, and square root of 2. So the tangent is y divided by x. So in this problem, it would be y is 1, x is 1. So the final answer will be square root of 3 minus 1. And that's the exact area. Now, again, if you put this on a calculator and hit the button, it would turn out to be about 0.73. So this is an approximate answer, but again, this one right here, as we've done several times, will be the exact answer, and that's the one you want. Okay, so there are some sample trig identities, and in a lot of cases, the most difficult part is just changing the trig function into a number. And again, if it helps you, draw a picture of your special angles, label the sides, then you'll know what goes into the function when you put it in a value. And that's it. So good luck with those.